Okay, my friends, so like I said in the notes, I've got a pretty foolproof way of doing these kinds of problems, these dimensional analysis conversion problems. I call it the have and the need. You start with what you have, and you work towards what you need, and you use unit fractions to get you from point A to point B. So let's start. In this one, we know we need to get the patient's weight in kilograms. So I'm going to put that unit over here, kilograms. Okay, that's what we need to get to. Okay, cool. We have the patient's weight in pounds. Okay, so that's going to be over here. We have the patient's weight in pounds. As a matter of fact, it's 157 pounds. 157 pounds. So our job is to get from pounds to kilograms. Now, the thing about dimensional analysis is you have to be able to get from point A to point B. In other words, both the unit of pounds and the unit of kilograms have to measure the same thing. And in this case, they do. They both measure weight, mass, I think is the technical term, but weight. I'm going to call it a weight. So that if they both measure the same thing, that means there has to be a conversion fraction, which is a unit fraction, between them. Now, if you're in the nursing program, you might already know this particular one. If you don't, you can always Google it. There are 2.2 pounds in 1 kilogram. Now, I'm going to write that down here for a second. There are 2.2 pounds in 1 kilogram. Now, if you look at that, 2.2 pounds in 1 kilogram, the way I've written it, which was completely accidental actually, it looks like a unit fraction because it is a unit fraction. We can actually remove the in and say there are 2.2 pounds per 1 kilogram. And that, my dear friends, is a unit fraction. You've got a 1 in the bottom with the kilogram. You got 2.2 pounds up top. Here's how we're going to use that to get from point A to point B. What we need to do effectively is to cancel this pounds. It needs to go away and be replaced with kilograms. Now, before you got to this class, I know you learned how to multiply fractions. And we're going to use that skill here because that's a fraction. And if we can multiply fractions, it's actually the nicest thing to do with fractions. It's one of the only things we'll do with fractions in here. But the problem is that those two numbers don't look like fractions. 157 pounds, that's just a number with a unit. Kilograms, that's just a unit. But the thing is they can both be fractions. Any number can be made into a fraction by placing it over 1. By placing it over 1, just like that. Now they're both fractions. So now we can combine that fraction with this fraction and get to that fraction. I'm going to put an equal sign right here. Now here's the thing. Let's think units before we do numbers. Numbers will come in a second. Let's think units. Unit-wise, we want to get the pounds out, which means we'd have to be able to divide the pounds off mathematically. The easiest way to do that with fractions is to be able to place pounds in the denominator of the conversion fraction. That's what this middle is going to be. Now here, when I wrote this down, I wrote pounds in the top. I wrote 2.2 pounds per 1 kilogram. But nobody says I couldn't have written it like this. That means that 1 kilogram per 2.2 pounds. Now, why would I want to write it like that instead of the other way? Well, quite simply, because if I'm multiplying these fractions like that, you learned a long time ago that when you have the same factor in a numerator and a denominator and you're multiplying the fractions, you can divide them off. Well, I'm going to grab a little pink marker here and do the exact same thing. I'm going to divide that pounds with that pounds. It's like they're not even there anymore. Because they're not. Because they're not. They're mathematically have been divided off and replaced with ones, technically speaking. That's one reason I'm happy. The other reason I'm happy is because look where kilograms is. Kilograms is now exactly where it needs to be. Which means, I'm going to erase this right here. I'm going to rewrite the math with all the stuff that divided off gone. This now over here is no longer 157 pounds over 1. It's just 157 over 1. And this is now 1 kilogram. Gram has an R in it, apologies. Over 2.2. Now, one of the units is gone. That's what we wanted. We wanted to get rid of the one unit and replace it with the other one. Now we can do the math like we did with unit fractions. In other words, we can separate out the numerical part, which is 157 times 1, which is 157, divided by 1 times 2.2, which is 2.2. The only unit left is the kilograms. And what? I'm having a hard time spelling today, fam. Kilograms. What is 157 divided by 2.2? Let's get it to the nearest kilogram. 157 divided by 2.2 looks to be about 71. So this 157 pound person is about 71 kilograms. And that, my dear friends, is dimensional analysis. Start with what you have, look at what you need, and come up with a fraction that can get you from one to the other. Let's have you try another one.